Hi everybody! So in today's video we are going to be learning a next rule for derivatives, which is chain rule. So chain rule is what we use when we are taking the derivative of the composition of two functions. You may remember learning that sometimes functions can be composed by combining or putting one function inside of another one. For example, sometimes functions can be written like this. H of x is going to be f of, and then inside of there, instead of an x, it would be g of x is on the inside. An example of a problem like this would be this one. Here we've got something to the fourth power, sort of a function that we're raising to the fourth power, but inside of there, instead of just x to the fourth power, we have x squared plus 3x, which is a whole nother function. So we've got layers of functions here. To take the derivative using chain rule, when you have a function inside of another one, here is the rule that we use. The derivative would be, step one is to take the derivative of the outside function, but don't change anything about what's on the inside. So leave the inside alone. Then you take the derivative of the inside function and you multiply those two things together. We call this right here the chain. It's the derivative of the inside of the function. So first, take the derivative of the outside and leave the inside alone. Then take the derivative of the inside of your function. To do this, I find using different colors for the different functions very helpful, especially at the beginning. So right now, if you have colored pens or pencils, I would suggest taking them out because I'm going to model for you how you can use different colors to help make this process a little bit easier. So in problem number 1, the first thing I want to do is identify all of the different layers of this function because it's easier to do the chain rule properly when you can clearly see the layers. So step 1 is just going to be to rewrite. Now we're not taking the derivative here, so this is still going to be f of x. The outer layer of this function is the fourth power, something to the fourth power, and the inner layer of this function is the x squared plus 3x. Then we're actually going to take the derivative using the chain rule. So f prime of x would equal. The first thing I need to ask myself is, how do I take the derivative of something to the fourth power? I'm going to pretend that this inside thing is not even there. That's why I'm covering it up. The answer is that when I take the derivative of something to the fourth power, I drop the 4 and I decrease the power to a 3. So that's my first layer of derivatives. Now chain rule says don't change the inside, so I'm just copying the inside exactly the way that it originally was. Then take the derivative of the inside as the chain. So the chain, the derivative would be 2x plus 3. This would be your final answer. Let's try this again for problem number 2. Again, I think it's going to be easier if we rewrite this so we can see all the different layers. So instead of having a square root, right away I'm just going to change that to a 1/2 power. So my outer function would be something to the 1/2 power. My inner function here would be 4x squared plus 5. Then I'm going to use the chain rule to take the derivative. So y prime would equal, and I need to ask myself, how do I usually take the derivative of something to the 1/2 power? The answer is I use power rule. So I would drop the 1/2 power and I would subtract 1 to make this power a negative 1/2. Now chain rule says don't change the inside, just leave it 4x squared plus 5. Then I'm going to take the derivative of the inside. So the derivative of 4x squared plus 5 would be 8x. This is an example where I can simplify a little bit. There was really nothing to simplify here. Nothing's going to combine or get any easier. I can't really distribute unless I write this out 3 times, and I that's not going to make my life any easier. However, in this problem, I can simplify. So I'm going to do 1/2 times 8x. So 1/2 times 8x gives me 4x. And I'm going to move this negative 1/2 power to the denominator. So the denominator here would be the square root of 4x squared plus 5, just dropping it down to the bottom. And that would be my simplified answer. Okay, let's take a look at another one. Now this is an example where we have more than one term in our problem. We have the 3 square root of 6x plus 7, and we have the 4x to the 5th. The 4x to the 5th is easy. There's no chain rule for that one. That's just the power rule. The problem that has chain rule is this part. Because in this one we have a square root, but on the inside there's a whole other function, 6x plus 7. So the first thing I'm going to do is I'm going to rewrite this in a way that allows me to see how to use chain rule. So I'm going to rewrite this as 3 and then something to the 1/2 power, because I know a square root is really something to the 1/2 power. And what's inside there is 6x plus 7 plus, and my second term isn't going to change. It's just going to be 4x to the 5th power because there's no layers here. It's just 4x to the 5th power. Now I'm going to use chain rule to take the derivative. So g prime of t, and I apologize, this should have been a t. That was a typo. My bad. And this should have been a t as well. I apologize for that. G prime of t would be. Now I need to ask myself, how do I normally take the derivative of something to the 1/2 power? And the answer is, I usually drop the 1/2, so I would have 3 halves, and I make the power now a negative 1/2 because I subtracted 1. Chain rule says, leave the inside alone, 6t plus 7, and then multiply by the derivative of the inside, which is 6. Now for the second term here, the derivative of 4t to the 5th is just 20t to the 4th. So that part was the easy part. Now we're going to simplify. So I'm going to go ahead and combine 3 halves and 6. So 3 times 6 is 18, divided by 2 is 9. I'm going to drop this negative 1/2 power to the denominator and rewrite it as the square root of 6t plus 7. And my second term here would be plus 20t to the 4th. And that would be my answer. We're going to go ahead and save number 4 for class tomorrow, and we will work through that one together before you guys start your practice. Thank you so much for watching, and I will see you for some practice.